Hello, welcome to another episode of ASMR You Sitting Comfortably. Now, thank you to everybody who watched my last few videos. My most recent one was looking at found objects on the banks of the Thames. I hadn't posted a video for a little while because I haven't had the time. But since lockdown lifted a bit, I've come home to Cardiff for a few days, and it's much quieter here, so I brought my equipment with me, and I thought I'd do a few videos. So in this video, I'm going to be looking at the Look It Up Book of the Earth. I've had this in my house. I don't really know where it came from. Quite an old book, I think, so maybe I had it when I was a child. But there's some fun stuff in it. I'm going to be doing some map drawing videos as well while I'm down here. But I thought I'd start by testing my equipment with this little video. Yeah, let's take a look. So, on the front cover, we've got a picture of a glacier here. A picture of what I think is probably Niagara Falls, maybe Victoria Waterfall, I'm not sure. And then here we've got what looks like a volcanic explosion. And the book is illustrated by Seymour Simon. No, it's not. I think it may be written by Seymour Simon and illustrated by John Green. And it's a Collins book. Collins do lots of kids' books as well as atlases and, non-fiction books. My mum is a teacher, so I wonder maybe whether she got this from her school. It's got quite a lot of drawing marks on it, indentations from where people have used it to lean on. Let's open it up. So, on the very first page, we have a view of the North Pole photographed by a weather satellite. You can see all the clouds swirling around. There's the top of the Earth there. The countries are sort of highlighted, but they're not amazingly clear. That looks like Scandinavia there, and Sweden and Denmark. So I guess that's the UK there. And here is a view of the South Pole, photographed also by a weather satellite. There's much more snow, as you can see. Cloud. Okay, so here's the title page, the Look It Up Book of Earth. So here there's a little picture of an owl. I think that's the Collins logo. And here it just says, Simon Seymour is a science teacher and writer with several children's books to his credit. A native New Yorker, he graduated from the City College of New York. He has also acted as a consultant and reviewer for various scholastic and children's magazines and has written articles on a wide range of scientific subjects. So, the illustrator, John Green, is widely known as an illustrator of children's books, particularly those dealing with astronomy and space. An enthusiastic amateur astronomer, he illustrated the Look It Up Book of Stars and Planets. He is a member of the Association of Lunar and Planetary Observers and of the American Association of Variable Star Observers. So I think this goes from A to Z. This page here is about air masses. I've got a diagram here of different air currents and warmths and where they come from and how they affect each other. I'll read a little bit of this. Air masses are large bodies of air which produce most of our weather. Depending on where they start from and whether they have travelled over land or over sea, air masses can be cool or warm, dry or moist. For example, moist air may come to Britain over the North Atlantic Ocean from Greenland. Warm, dry air will travel overland from North Africa or southern Europe. Air masses also come from the Arctic Ocean, from Eastern Europe, and from the subtropic zones far to the southwest of Europe. So, these are coming from the subtropic zones here, I guess. This probably goes all the way down there towards the equator, the tropics. And here's the cool air coming from the north. All these different air masses are forever pushing against one another. Wind currents carry the air masses along. It is like a battleground of the atmosphere. First, one air mass pushes through, then another. Each air mass brings a change in temperature and humidity. This helps to explain the changeable weather of Britain. Britain does indeed have very changeable weather. London is quite warm. There's a lot of people there. That's partly why, and also because it's in the south. But in Cardiff, it rains a lot and it's a bit colder. So here we've got a picture of Antarctica. Mount Erebus, a typical Antarctic landscape. And here our illustrator has drawn a few penguins. In the far south lies a mighty continent wrapped in ice, Antarctica. It is surrounded on all sides by the stormiest of oceans. Almost the entire continent lies hidden under a mountainous pile of ice. In some places, the ice is more than 3 miles thick. The ice covers the entire mountain ranges and pushes far out to sea from most of the coastline. The area of ice covering Antarctica is bigger than Europe and the United States put together. Antarctica is the coldest spot on the Earth. Scientists wintering there have recorded temperatures colder than minus 64 degrees centigrade. Because Antarctica is south of the equator, the seasons there are the reverse of those in Europe. While we are having summer, the Antarctic is having winter. But even when the Antarctic has summer, temperatures never rise very high. At the South Pole, the temperatures may go as high as 17 degrees centigrade and rise above freezing point in the coastal regions. So there's a polar bear. Moving from flow to flow. Let's read a little bit about polar bears. Polar bears are also a problem. They can swim from flow to flow. The bears sometimes board the island stations and prowl around the camps. They knock over equipment and get into food stores. Meeting a large polar bear can be dangerous. Other occasional visitors to the camps are Arctic foxes and seals. Scientists living on the ice are seeking to find out how the Arctic Ocean influences climate and weather. The scientists hope to learn what happens to the ice pack in summer and in winter. They are also studying the living things that make their homes in the cold, ice-filled ocean. Unless, of course, they get eaten by polar bears. I like the illustrations in this book. They're kind of like doodles. They're not amazingly detailed, but they tell you what's going on. Here's a picture of our atmosphere. Here we've got the troposphere. I suppose that's the air we live in. And above there we've got the stratosphere. Above that we've got the ozone layer. Above that the mesosphere. And above that the ionosphere. Let's read a little bit about the layers of the atmosphere. Air has weight. The air needed to fill a large toy balloon weighs about 1 ounce. This does not seem very much, but the atmosphere extends upwards for many miles. The column of air pressing on your body weighs over a ton. At sea level, 14.7 pounds of air pressed down on every square inch. Of course, we do not feel the weight of the atmosphere. Our bodies can withstand the great pressure because the same air pressure is inside us, pushing outwards. Air pressure is greatest at the bottom of the atmosphere. Higher up, the pressure becomes less. The bottom layer of the atmosphere is called the troposphere. The troposphere is about 10 miles thick over the equator, but only 5 miles thick over the poles. The troposphere includes about 9/10 of all the air and almost all of the water vapour. The clouds, the great wind belts, and the weather are all part of the troposphere. Air temperature falls the higher we go in the troposphere. The stratosphere is the next layer of the atmosphere. It reaches a height of about 30 miles above the Earth's surface. Here, the air is very thin and the clouds are few. Jet planes can fly at high speeds because of the low air resistance. Surprisingly, air temperature goes up in the stratosphere. In the upper part of the stratosphere is a layer of gas called ozone. The very thin air making up the ozone layer absorbs most of the ultraviolet rays that come from the sun. A small amount of ultraviolet rays can cause a sunburn. A large amount can kill. The ozone layer shields us from these deadly rays. Thank you, ozone layer. The temperature starts to drop again above the stratosphere. The temperature becomes lower up to a height of about 50 miles, then it begins to rise again. This zone of falling temperature is called the mesosphere. Above the mesosphere is the ionosphere. The ionosphere is the Earth's boundary with outer space. Upon this region fall all sorts of radiation from the sun, cosmic rays and many other kinds of rays. Electric currents flow through the ionosphere. Temperature goes up quickly in the ionosphere. On the height of 300 or 400 miles above the Earth, the ionosphere thins away into the emptiness of space. I like the way this book is written. It's got a kind of dramatic flair to some of the ways things are phrased. It's nice. It's a picture of a cavern. I suppose this is a stalagmite, I think, because it goes upwards. And this is a stalactite that comes down here. Large underground caves are called caverns. They are usually found in layers of limestone rock. Water from streams or from rainfall trickles through the cracks in the limestone. As the water with carbon dioxide dissolves in it seeps through the cracks, it dissolves and carries away small amounts of limestone. The cracks gradually widen into caves. Over thousands of years, underground caves have become large enough for people to enter. Sometimes the roof of a cave near the surface of the ground may weaken and fall in. The surface opening is called a sinkhole or a sink. Water often collects in sinkholes, forming sinkhole ponds or lakes. Limestone caverns often have slender, icicle-shaped stalactites hanging from the roof. Stalactites form as water drips slowly from the roof. Each drop leaves behind some of the limestone dissolved in it. As the drops splash to the floor, they leave more limestone. Upward growing stalagmites form on the floor of the cavern. The largest known underground chamber is in the Carlsbad Caverns, New Mexico. The most extensive cave system is Mammoth Cave, Kentucky. The deepest caves are found in the Pyrenees. In Britain, the largest caves are to be found in South Wales. Two of the best-known caverns are Gaping Gill, Yorkshire, and Wookey Hole, Somerset. So, I'm currently recording from South Wales, where we have some of the largest caverns. I suspect that you will find these in the valleys and in the Brecon Beacons, a national park just about an hour's drive from Cardiff, a little bit less even. When I was little, I couldn't tell the difference between stalagmites and stalactites, or rather I got confused by their names. My teacher told me when we were in Wookey Hole Cave in Somerset that you remember them because stalactites hang down like tights and stalagmites go upwards. I'm not sure it actually makes a lot of sense because I guess tights don't really hang. They do if you hold them up, I guess, but it always worked for me to remember them. Here we've got some pictures of some what looks like geothermal activity. I'm not going to read this one here. Okay, so here, this, I suppose, a 10-foot fault scarp caused by an earthquake. I suppose it tells you what that means here. I'm not going to read that for now. Climate. Some pictures of different climates here. Cold climate. Husky dogs, cute husky dogs pulling the sledge. Warm tropical climates like the ones found in rainforests, the tropics, near the equator. Ocean climate here. It looks like a British coastline. The average weather in an area over a long period of time is called the climate. There are many different kinds of climate. Some are hot, some are cold, some are dry, some are wet. Some kinds of climate have dry seasons or rainy seasons. Other kinds of climate are rainy or dry all through the year. The climate of an area depends on such things as its latitude, its altitude, and the winds that blow over it. Climate also depends upon whether the area is close to or distant from any ocean or large sea. Some of the words used to describe climates in Europe are subpolar, Mediterranean, semi-arid or dry, maritime, near large bodies of water, and continental, in a large land area. How would you describe the climate in your area? I don't know how I'd describe the climate in my area. I suppose in Cardiff, we're near the sea, near a small sea. So it's kind of maritime. But because we live in a city, because the bay and the water around Cardiff is not really that wild, it's quite still, it's in an estuary. It has a tide, but there's a big development that's put a sort of man-made lake in front of it. We don't necessarily think of Cardiff as really that much of a maritime place anymore, although it used to be. I suppose that's more social, cultural than it is climate, though, and it is very wet and often cold in Cardiff, so I would say that's probably maritime. Clouds. Who doesn't love clouds? Here we've got cirrus clouds. Those are those little light ones you get when it's really sunny that just stripe the sky. Here we've got cumulus clouds. Cumulus clouds. I'm not quite sure. That's your classic cloud there. Stratus. And nimbostratus. It's a nice name, isn't it? Nimbostratus. I should say that in this video I think I'm going to do just A to C. And then I'll release another part with the later letters and then the later letters. So a sort of series of videos. Yeah, I just took a small break then. Someone came home, so I had to deal with that. So the angle might be a bit different now. I actually think it's a little better. So I will pick up where I left off. Clouds are made of millions upon millions of tiny water droplets or ice crystals floating in the atmosphere. When warm air near the Earth's surface rises, or is forced to rise perhaps by meeting a hill slope, its temperature falls. It comes in contact with cold air higher up, and some of the invisible water vapour particles present in the air change into tiny water droplets. When you see masses of these minute droplets, you are looking at a cloud. Sometimes air rises very slowly over a wide area and cools very slowly in layers. The clouds so formed are called stratus-type clouds. If the air rises quickly over a smaller area, the clouds are called cumulus-type. 4 types of clouds commonly seen are cirrus. These are thin clouds, sometimes called mare's tails. Usually made of ice crystals, cirrus clouds float at heights of 5 to 8 miles. Cirrus clouds are usually mean fair weather for a day or so, followed by snow or rain. Cumulus clouds, thick, fleecy white masses of clouds. Cumulus clouds look like puffs of cotton wool in a blue sky. They appear on fair days. In the late afternoon, the wind may break them up. Then they are called fractocumulus. Fracto in front of the name of a cloud type means broken. Stratus. These clouds give us a grey day. They stretch across the entire sky that we can see. A light drizzle often falls on such a dreary day. Nimbostratus. These are heavy rain or snow clouds. Nimbostratus clouds are dark and threatening looking. They come at any time of the year. Don't confuse them with cumulonimbus, the thundercloud, which comes mostly during warmer seasons. Here's a picture of the cumulonimbus. It's really tall and like a big column. It happens after hot weather, I think. Response to hot weather. It's nice talking about clouds. As I look up my window while I do this, I can see some cumulus clouds floating along a lovely blue sky. I'm not going to talk about coal, as interesting as it is, but here are some pictures of it, different types. I imagine this is the kind of environment where coal was formed, the prehistoric environment. I think the next thing I'm going to talk about, the continents, seeing as I do lots of map drawing videos. There's a lovely little map here. continents. The 6 major land areas on the Earth's surface are called continents. They are North America, South America, Eurasia, Europe and Asia form a single land area, Africa, Australia and Antarctica. The continents also include the underwater lands that surround them, the continental shelves and slopes. So, this page we have something called the Coriolis effect. It's the effect of motion, any body of motion, such as air or water, the way it's pushed because of the rotation, I think, of the Earth, and because, I'm not going to talk about that. What I am going to talk about is crust. The crust is the outer layer, or skin of the Earth. It's about 20 to 30 miles thick under the continents. Under the oceans, the crust is only from 3 to 10 miles thick. Compared with the size of the Earth, the crust is very thin, thinner than the peel compared with the rest of an apple, and is very thin. Granite is the main rock that makes up the continental crust. Underneath the granite, there is basalt, which is also the main rock of the ocean crust. Yeah, we're going to see the basalt there. That's the ocean crust there. Granite here, just above. Let's learn about how the crust was formed. Scientists know that the Earth was in a hot, molten state thousands of millions of years ago. According to some scientists, the light materials of the crust floated on the heavier materials underneath, much as oil floats on water. As the crust materials cooled, they separated into a lighter and a heavier part. The lighter part became the granite of the continents. The heavier part became the basalt of the ocean basins and the underlying rock of the continents. Other scientists believe that the entire Earth was covered by a crust of basalt as it began to cool, but from beneath the crust, hot materials were still escaping, and very gradually the basalt was replaced by granite. As more hot materials erupted, the masses of granite grew until they became the continents. Some scientists say that the continents are still growing the same way today. Material on the crust. Much of the crust is hidden by loose rock and soil. The blanket of loose material is called regolith. Regolith is found in many forms. It could be the soil of a farm or park, or the sand covering beaches, or rocks and boulders eroded from mountains. Regolith can be moved easily or dug up. Below the regolith, all over the Earth, is the unbroken solid material of the crust. It is called bedrock. In hilly or mountainous areas, bedrock can sometimes be seen at the surface, or it might be exposed by road making or building construction. That's the crust. Okay, so I think I'll talk about both of these, and that's going to be the end for this video. Crystals. Minerals are sometimes found in the form of crystals. Crystals may be different shapes and sizes, but crystals of the same mineral have the same shape. Quartz forms 6-sided crystals. Salt crystals are cube-shaped. Many kinds of crystals are beautifully coloured and transparent. Quartz may be white, rose or purple. Purple quartz is called amethyst. Amethyst and many other rare and beautiful crystals such as rubies, emeralds, topazes and opals are called gems. There's some topaz there and there's amethyst. But not all crystals are valuable gems. Crystals are formed when molten rock cools. The slower it cools, the larger the crystals that are formed. If the molten rock comes to the surface, lava, it may cool so quickly that no crystals will form. But molten rock slowly cooling deep beneath the Earth's surface, magma, may grow giant-sized crystals. Cyclones and anticyclones. The basic reason for cloud formation is that air cools as a result of rising, or being forced to rise. Where this uplift of air takes place, it usually causes low atmospheric pressure. We call this low pressure area a cyclone or a depression. On the other hand, where air at upper levels sinks towards the ground, the atmospheric pressure rises. We call this high pressure area an anticyclone. In the northern hemisphere, the wind always blows with low pressure, and on its left, it's blowing anti-clockwise round a depression and clockwise round an anticyclone. It blows anti-clockwise round a depression and clockwise round an anticyclone. In the southern hemisphere, due to the Coriolis effect, the directions of rotation are reversed. Depressions are often hundreds of miles across. They are responsible for much of the rain and snow we get. Anticyclones are also large. They usually bring settled weather. In some parts of the world near the equator, depressions can produce violent tropical storms which often endanger lives and property. In the West Indies they are called hurricanes, whereas in the China Sea these cyclonic storms are known as typhoons. In Western Australia, such a storm is known locally as a willy willy. That's a very funny name. So, I've done A to C, or most of A to C. That's all I'm going to do for this first video on this book. I'll return with another sometime soon. All that's left to say is to talk about my featured ASMR artist for this video. Every week, every video, I'm going to talk about a different ASMR artist for you to check out. This week, I want to talk about Let's Find Out ASMR. It does really informative ASMR videos, long form videos about the world, about space, about different things. They're really educational. They're quite different in style. I think they're quite unique. And I've learned a lot from them. He obviously cares a lot about the content he puts out, puts a lot of detail and time into it, and I really appreciate that. I'm sure if you're looking at my videos that you probably already know about his, but if you don't, then I will put a link in the description below this video and you can check it out. Okay, thanks for listening.